When solving inequalities without a graphing tool, we need to be able to graph the relationship, and we also need to determine the solution area. So to do that, we need to figure out what is the boundary line, which side of the boundary line we're on. Again, we should be looking at above or below. And then we need to do the same for the second relationship and figure out the overlapping areas that represent the solution to the system. So the first things first, we need to be able to graph this inequality. Okay? And so it's a linear inequality, so there's a few ways we can do this. We can make this into y equals mx plus b. Since it's a linear inequality, for the first one, I'm going to graph this just using the intercepts, okay? So that we can remember all the different techniques that we have. So here I'm just going to make a table of values. When x is 0, I plug in 0, I'll solve for y. Okay, so I end up with -3 equals 6, y equals -2. So -2 is my intercept. Then I'll do the same for 0 for y, and I end up with 2x is equal to 6, so x is equal to 3. Okay, so using those intercepts, I'll graph this line. So it's not equal to, so I need to draw a dotted line. So I'm just going to draw a dotted line through here. Okay, and then I have to determine which side of that's on. Now, since it's not a y equals mx plus b, it's a little bit harder to determine if I'm above or below. So what I'm going to do is I'm just going to test a coordinate. So I'm going to test 0, 0, and see if that fits this inequality. So I end up with 0x minus 0y minus 6 is less than 0. That's okay. Okay, so that this area then represents my solution for that inequality. So now I'm going to move on to the second inequality here. This one I will graph as a y equals mx plus b. So solving for y, I get y minus or greater than or equal to, and I'm going to get -3 on the other side, plus 4. And solving for this, I get -3 over 2x plus 2. So it's got a y-intercept at 2. It's got a slope of -3 over 2. So I'm just going to draw a little bit of that slope in. Okay. It is equal to, so I'm going to have a solid line that goes through those points. Okay. And then since it's y is greater than or equal to, I know that the solution area should be above. So I'm just going to shade above. Okay, so those are the two individual linear inequalities. Again, I need to find the boundary line. I need to know if I'm above or below. And the solution to the system then becomes the overlap of those two. So it includes that line. It doesn't include this line. And it's all the area where we overlap. So that two-dimensional solution can be shown as an area shaded in two-dimensional space, or on the xy plane. So that's essentially what we're going to do, except we're going to now add in the fact that we could have quadratic inequalities. So when I graph a linear quadratic system, really I'm just doing the same thing. I just still need to figure out the boundary line. Okay, this one here is y equals mx plus b, so I'm going to just draw this with my slope and intercept. Okay, so as I draw this in, it's going to be a dotted line. Okay, and I know that the solution is above. Now this time I'm just gonna keep track of it and just know that it's above. And when I solve or draw this quadratic inequality, I'm just gonna keep track if it's above or below. So I'm just gonna draw this one in red. Okay, so to draw this, it's in the factored form, so I'll use the intercepts. So there's going to be at 3, 0, negative 2, 0. It's upside down. I do need to find the vertex. Okay, so if I want to find the vertex, I'm going to make a table of values over here. Okay, so when x is 0.5, I'm going to plug in. So I'm going to end up with negative 2.5 times positive 2.5, which is going to give me 6.25. Negative 6.25, and then it's going to be positive 6.25 with the negative in front. So there's my coordinate. My vertex is about there, and it's equal to, so I'm just going to draw in a solid line. Okay, so remember, when we draw in our parabolas, I'm going to expect to see symmetrical points. So in this case, I'm using the zeros and the vertex. So there it is, and I have to decide, am I above or below? So this one is below, and for the green I'm above. So the intersection area that I want is going to be below the parabola and above the green line. So that area represents our solution. And I'm just going to test it. I really should test, so I'm going to test again. The coordinate I like to test is 0, 0. I'm going to test it in both. So when I test 0, 0 in the first one, I get 0 is greater than negative 4. That's true, so that's okay. The 0, 0 is okay for the linear equation. And then for above the, for the quadratic, I'm going to end up with 0 is less than or equal to. That's going to be negative 3 times positive 2. So negative 6, negative is positive 6. That works as well. 0 is less than positive 6. So we have, it's okay for both equations. So this is, the solution area should be above the line, straight line, and below the parabola.